What's up, everybody? Welcome back. Today I want to work on GPU selection in Wayland. So we have kind of been writing over a long period of time a Wayland client and a Wayland compositor at the same time, right? So here is our little Wayland compositor demo. It's really not very good right now. We have like our mouse in here. We have one window that is being rendered on some background, right? Wowzer. And this is the same program. If we go like zig build and zig out bins Wayland client, right? That same little spinny monkey head can be rendered here at the same time, right? That's not good. That's a bug that we should definitely fix at some point. But the way that this works is you kind of have this like protocol that you speak, Wayland. And the compositor sits here, over here, compositor or window manager, whatever you want to call it. And he exposes a little guy, some like ... Wayland 0 file socket. This is a Unix socket that you talk over, right? Then when he wants to render, he will also, like in the case of our compositor, he opens another file, dev dri card 0. And he sets up like OpenGL on this thing. If I look at like what's in dev dri, right? There's like 4 things in here. And if I look at this like by path, we can see that there's like 2 guys on PCI device 3 or maybe bus 3, I can't remember, and PCI device 12 or bus 12, whichever fucking one it is. And what these represent is one of these is the integrated GPU in my calling it GPU in CPU feels wrong, but I guess that's kind of what it is, right? I buy a CPU, I plug it in, and that thing is more than just a CPU. It's a CPU plus some peripherals, and one of those peripherals is like an integrated GPU. And then I have one plugged into the PCI slot on my motherboard. Probably this one. I'd have to check. And it's much more powerful, right? Also, depending on where these things are plugged in, where the rendering should be done kind of changes, right? So like you might have, I've got my tower. If I look at the back of my PC tower, whatever, there's like, the discrete card just kind of has some ports here. And then the motherboard kind of has like another output here, where if I plug the monitor into here, my monitor is plugged into the integrated GPU. And if I plug the monitor here, it's plugged into the discrete GPU, right? So like, depending on where I'm plugged in, it would probably make sense to do the rendering over there, right? Because if I render on this card, but my display is over here, then I have to render over here, then copy to the memory that this guy can access, and then display, right? So you've got like extra latency there that you don't want. And then it kind of goes to reason that if I'm displaying on this monitor, then all of the windows should also display on this monitor, right? We haven't really got to windows yet. But when a window tries to speak to the compositor, he's going to open up on this socket, talk some stuff, right? So I have like my window over here, Wayland window. And one of the things that he's supposed to do is he's supposed to ask, or the compositor is just supposed to kind of like let him know, like, hey, what GPU should I use? Because he, again, also just opens in our system, dev dri card 0, right? And in reality, what should happen is the compositor should check where shit's plugged in, or maybe use some like more intelligent heuristics like, oh, we are rendering something complex, so we should use like the heavier GPU, or like maybe we have things plugged into both monitors, so whichever window is showed on whichever monitor should probably use that GPU. Or if you're like playing a video game, something like high graphics, whatever, right? He should have like some heuristics to pick which GPU to use like more intelligently than just like 0. And then this guy needs to ask him, who do I talk to? And so that's the plan for today, is try to like set that up. So step 1 is kind of take our compositor out of the equation and use kwin, right? This is just like, a real window manager, like what is rendering these windows right now. We should be able to see what he's going to tell us to do, implement whatever protocol that is, and then from there, loop back and implement on our compositor once our client works correctly. You know what I mean? So that's the plan. That is the plan. So let's get moving. 04 52. So we did a bunch of spelunking in this world yesterday. And it turns out that there is this Linux DMA buff protocol. And one of the things that he provides us, like we already use this guy to create buffers to render on, like when we render, we like how do I say this? We do some OpenGL calls to draw our little monkey head, right? This gets like drawn in GPU memory, right? This is living on physically on this discrete card in its RAM somewhere. And we get like a handle to this thing through some like file descriptor. Like basically like Linux allows us to export these things for transfers between processes to say like, hey, compositor, here is a buffer on that GPU. Could you render that thing? And so we transfer that over Wayland. And the protocol that we use for that is this like Linux DMA buff protocol. So we already have this guy set up. But we are not calling anything related to this like feedback thing. So one of the things that's supposed to happen, I believe, is we are supposed to ask for default feedback when we first boot up. And we say, hey, send all messages related to feedback to this guy, this like new object that we created. And then the Wayland compositor, I think, will say, hey, render this device. And also, while we're fucking here, here's like what fucking formats you're allowed to use, right? Which is maybe interesting, right? So this is like memory mapped size of format table. So we should probably also select like, you know, what buffer format we're using, like RGB 888 or like alpha RGB 8888, or, you know, maybe we're using floating point or something. Who knows? Like whatever storage format the GPU wants, we should probably try to like pick from the available formats here. But yeah, let's just kind of see how that goes. So in our client somewhere, WL client maybe? I don't remember what we called all this stuff. It looks more like Windows probably is where we actually do negotiation of stuff. So on initialization, somewhere we must get access to this like ZWP Linux DMA buff thing, which we have here, DMA buff. So how is this constructed? On initialization, we bind interfaces. So we like, oh, I see. We say, hey, could you let me know what interfaces you have, and when you tell me about them, I will bind to the one I care about. Great, and one of those is there. So by this point, all we've done is kind of said, okay, there are these interfaces we can talk to. And then I guess it's kind of whatever order we want, we do things in. Here is where we initialize our OpenGL stuff. So it would like kind of make sense to not initialize OpenGL until we have retrieved which things we care about. So I think that we should just be able to call here, like, bound interfaces, DMA buff, get surface feedback. So I think we're here supposed to go like, surface feedback is client new ID of Wayland binding ZWP DMA buffer feedback. Yeah, that's what they want, right? Yeah. And then we call that with this thing. Okay. This guy wants like a writer. Okay. I guess. Okay. This guy is mad probably because it's more like this. Why does this feel... Oh, get default feedback, my bad. And then, is this wrong? Oh, like ID here. Okay. So here we say, yo, let me know. And I guess we are supposed to maybe like wait for messages now, probably. So it's like, while client, I guess it's like client event iterator, probably. And then it's like, I think we're supposed to like retrieve events. Here we like wait for something to happen, and then we assume once something has happened that we have everything we need, so then we can kind of like iterate these things, right? We can say like, while it next, no, it get available event here, I guess. we look at that event, so we probably, I assume that we like switch on something. Probably like this. Okay. What is he pissed about? Oh, here. Okay. So then it's like, what are our event types? Wayland incoming messages, right? So what do we do? I'm sure that we've done this somewhere else, right? When we did like bind interfaces, I think we kind of did the same thing. So we have like display registry, else log unused event, I guess is probably what we're looking for, right? Else log, where was that? WL client, log unused event of event. All right. But in our case, we're probably looking for something like, I'm kind of hoping that this just kind of shows up now, right? But I guess, okay, here's what we'll do. We'll just log all events that come in and see what happens. You should always prefer the per service feedback. The default feedback is the fallback as far as I know. Yeah, but when we looked at the EGL implementation yesterday, I feel like we saw them kind of saying like the surface feedback is better, but we don't know how to fucking use it. Maybe I misunderstood what I was reading. But when we went into GPU testing of, where was this? Source Mesa. It was like DRM Wayland probably was where this is implemented. We saw something about surface feedback. Platform Wayland. And in this like surface feedback thing, they had like when you get the main device, they had this thing in here that were like compositors may support switching render devices and change the main device of the DMA buff feedback. In this case, when we relocate the buffers and surface, blah, 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 they're basically just like, we don't fucking know what to do here. Right? So when they get surface feedback, they don't fucking use it ever. But when they do the default feedback, they do use it. So here on default feedback, they just set it. So I think what's happening here is they're kind of saying like one time on initialization, we will call default feedback, right? We're seeing like this is like in some initialize call. We will ask for like whatever they want by default, and then on the surface ones, like we'll just write down for ourselves later. We fucked up, right? So I think that if normal EGL is behaving that way, that's plenty good enough for us as well, even though it is wrong. You know what I mean? Because if everyone in the real world is using EGL to get their OpenGL contexts, and so like we only have to be as good as they are. But I agree that it would be better if we handled that, and maybe we can in the future. But I think for now, just working off the default one is fine. But I could have very well misunderstood that code that I was looking at. But at the very least, it's what it's what I saw. So, we will do that as well. The compositor may switch device at any time, so they really are really just not taking advantage of the surface feedback. It seems like they're just using the worst case always, no? Yeah, I mean, it could be that they notice, it could be that they stay registered to default feedback. So it could be that, like, if my compositor maybe says, hey, everyone switch to using this GPU versus, like, this surface switch using to that GPU, if that makes sense. It might be something like that. I'm not sure. But I do like mostly agree with you that it's like I don't necessarily think that this is like correct in like the strict sense of the term. Okay, so we're looking for ZWP. Oh no, wait, we're just gonna log and see what happens, right? I forgot. Okay. It looks like we don't see any unused events here. I guess these are debug logs. So we need to change this guy to set our debug level to debug. Okay. Oh, fuck. Oh, no. Okay. Temp text. All right. So, can we look for unused event? Here we go. So here we see exactly what we were hoping for, right? He sends us a format table to file descriptor. This is a little concerning. We would probably leak this format descriptor, or this file descriptor, sorry. I think it's very likely that we leak this. But then we see that he says main device and then done. On done, are we supposed to destroy this thing? Looks like no. It looks like we get to choose when to destroy this whenever we want. So I think we just hold this thing forever and wait for main device changes and log them. Okay. But it looks like before we start, we do have this thing. So ZWP Linux DMA buff feedback. What was it? V1? Feedback or something. So then I think it's like this thing is another type, I think. I don't really remember. Right, so this guy has incoming messages here, where incoming message is another union, right? So here we switch on this guy now. And here, if it's main device, we do something. And then while we're here, we should be looking at a format table. And here we should be like, close FD if needed. I actually don't know if our Wayland client supports reading file descriptors this way. He might not. Does he do this? Yeah, I think we only support client to server file descriptors, not the other way around. So maybe it's fine. It might be fine. Okay. Why do you have the vars and statements within its own block? Just so I don't lose them. I don't like leaking scope if I don't have to. Okay, so what is this thing? Main device is a main device who has device constitute. Okay, so here we should be like desired GPU, desired device is this thing. And if we see this, we probably do this. Like, main device is null. Then we do here. Was it main device or main? I think it was like this, right? And at the end, we break block main device. And then here, I guess we throw that in here. Okay, this thing should be const. So true right now. And then he's like, no field named, was it device? I forget already. Yep, and then this init now is like, sir, could we please take in desired device? And here we'll say, desired device, or else we will fall back on just the default. You only do this for GPU selection, not format and modifier selection too. I think we probably should do that eventually, but let's start with GPU selection. Because you're right, this should also, you know, should come from Wayland. But let's just see if this does something. Okay. Oopsies. So this is mad about an unreachable here. Okay. That's interesting. So this is a non-absolute path? What in the fuck is going on here? What is this thing? What the fuck? Did I not new line? I forgot to new line. It's just nothing? Oh, maybe I forgot to copy it out. I always do that shit. Because this thing is sitting in some, like, temporary memory right now, and so I need to pull it out. Desired GPU device buff. Fine. Fucking fine. So this is like uh mem copy into desired device buff 0 to device plan. Is there a better way to do this? Yeah, let's do this. Stood heap fixed buffer allocator initialize with this thing, and then we can do like this. Dupe U8. Boom, boom. Yeah, something like that. Something like that. Still empty, huh? I'm seeing K1 do some funky stuff with formats and modifiers. I'm doing per service feedback. Oh yeah, I mean I think that's for if you want to do video rendering. I've read that you're supposed to like my GPU I think has like one extra surface or one extra like hardware composited buffer that you can render to specifically for video decoding, right? The idea being that you're like already doing decoding on GPU into these like YUV buffers. And so like most things don't support YUV formats, but this specific like video playback buffer does. So I think that's probably like the funky shit you've seen, right? Is like Kwin is saying, hey, if you want to do video playback, like use an extra surface with these fucked up parameters. Video rendering is a whole rabbit hole. My experience is just YUV formats occasionally pop up. Yeah, makes sense. Makes sense. Got main device. Like, how bad am I fucking this up? Okay, so this thing is just fucking empty. What the hell? What the hell? What is happening? Huh. Very interesting. Main device is a main device constituate. Are we like fucking up our decoding of this somehow? It would be weird that only this guy is failing. Let's look at this main device thing. Oh. It's not a string. It's an array that we are supposed to reinterpret as a dev t value. That's interesting. Okay, can we like look at the bytes of this thing then? That's crazy. Ah, I see. I see. So if I like ls-l dev dri, we see those numbers here, right? 226.0, 226.1, 226.128. That's this, right? 226.128, this guy. So we have to what? Like how the fuck how do you index like what do I do with this guy? Open dev node by dev t. Like what is that? Dev t. Dude, that's crazy. How am I supposed to know which one that like where that is? Because I have to open this file somehow eventually. So surely there's some way to like access these by their dev numbers? By path? Maybe not. I mean, there's got to be some sort of like Linux call to go the other way, right? Is there some Linux call I can use to resolve register dev file handles for a dev T? Minor and major macros, but those are gonna be like file paths, right? If I remember correctly, like you can create like an arbitrary file path out of these things by just calling like make node or something. And you can do like make node like dev literally anything I want, like 226, 129 or something, like something along these lines, and it will just like make the same file but like in some other path, right? Um um sysdev. This is probably what I'm looking for, right? So I'm looking for like what was it? It was fuck, I already forgot. 226. Do I see a 226 in here? Yes. Yes, I do, but this doesn't go where I want, I don't think. Um, no POSIX call or anything? I think you just have to compare with each render node. Yeah, I guess that's not crazy, right? Just iterate things in dev DRI, stat them, get their handles. Yeah, yeah, I guess that's crazy. What a weird. Is that not what you want to the UID path? No, I think that this gives me like actually something else. We could check. Right, so if I look at like this is not like this is the sysfs directory associated with this device, but not the file handle for the character device that I can call ioctls on, if that makes sense, right? This is not dev DRI this thing, right? This is like something else. Which is confusing. But yeah, I think I just walked the shit in dev DRI and figured out. That's so funny. Um so I guess we go like for I guess it's like here. If main device. This is now like dev T. And then we do like break block resolve DRI handle from dev T. Uh which is like this. Resolve DRI handle from dev T. Val const u8. This thing's optional. If const, this is like val is val opt, or else return dev dri card 0 something. I don't know, man. We'll figure it out. I have no idea. My experience with this comes from Vulkan, where you get the major and minor versions in render node type when querying available devices. That makes sense. That makes sense. Okay, so we go like major is val 0, I think. Minor is the second one. And then I think it's just like, surely we do something where this can surely fail. And we do something that's like, open dir absolute of dev dri. And we want iterate capabilities, please. While we want like dir iterate, okay. And while we iterate these things, we get some entry, okay. And this entry name, what is this? I actually don't know if this is gonna be relative or not. Let's just check. unreachable, and we'll reference these guys that doesn't bitch at us, and then this is main vice. Hello equals dev t. All right. This thing needs to be tried, I guess. Sure. Okay. So it looks like these are relative paths. Relative paths. I didn't new line, but they are relative. It's fine. So this is like a dir stat entry name like this. And where do we get the major minor in here? Use and where rdev from stat. The stat structure. See stat 3 type. I didn't know that existed. That's cool. So we have dev t rdev here, which it feels like we don't have in this. Probably because this is some like generic stat. Unless mode? Nah. It looks like maybe we're supposed to call POSIX stat and deal with it from there. I feel like it's something like that. Just one quirk, but the idiot told me that the memory layer of dev t is not stable to find, so it advised me to use macros. Yeah, I've seen that too. I assumed that that was not from... I didn't realize that applied to this transfer format here, but I guess it makes sense, right? So if they're actually sending me a U64, which I think they are actually, now that you say it, it feels like that is what they're sending me. Because it was 8 bytes. Maybe we just compare with the U64 directly. I think that's a good call. So let's do this. Which means that this guy here is kind of like this. And then this is more like, I guess also this allocator needs to go here. Somehow. Then this guy is like a stud mem, like read int? Is that what I want? This doesn't feel right. As a 2 value, bytes 2 value. Yeah, this is what I'm looking for, I think. U64 from device. Feels kind of right. Okay. Okay. When I each next here, do I need to like close this shit when it comes out? Doesn't look like it. Okay, so I think I want to call like stood POSIX stat on this thing, right? So this guy... Interesting. So this guy on Linux calls Linux statx here, which I guess is like the stat from dir thing. And then this will give me back rdev. Oh, interesting. So this does have major minor, which I feel like I didn't see on the POSIX stat one, which is funny. Right, we saw from POSIX, we had POSIX stat. I feel like we saw that as an R64 or a U64. Yeah, interesting. Interesting. So, okay. man to stat. Is there like some sort of like POSIX stat from dir? F stat? F stat? F stat? F statat? F statat. F stat at. File stat at this. That's what we probably want, right? Stud POSIX F stat at. So this is dir handle fd, yeah, into entry name. We also want flags, which I assume we can just do 0. And then we do like if stat rdev is equal to val, return alloc. We probably want to do like stud path, fs path join, I guess, with the dev dri and the path entry.name, right? Something like this. Something like this. And then if we get to the end, we go stud log warn, could not find render handle, returning default. Boom. Boom. Okay. Default card, dev dry card 0. Boom. 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 All right. Okay. Let's see what happens. Okay. Looks like something somewhat sane happened. Oopsies. Yeah, here we go. Dev DRI render D128. Let's go, baby. So we have now successfully got the right guy from the Wayland compositor. That's pretty sick. Pretty sick. So we should also probably be looking at like the available formats and flags. If the device is the selected one or something. But I think that, you know, if our GPU doesn't support, like, if they don't support XRGB 888 or whatever we picked, GBM, was it system zig here? Is it this one? Yeah, if they don't support XRGB 8888, then like they can fuck themselves. You know? You know? Are you using the linear modifier? I don't know what that means. So who maybe let's try to do the same thing from our server now. So presumably, I think now, we will be falling back on default now. So maybe here we should warn as well in our little guy. Also, this should be a function, right? This should be a... I guess also we need to like destroy this surface feedback if we don't want it anymore, or we need to write it down somewhere. How does this get resolved later? Handle event comes from event. Oh, it just knows. So I don't think we need to write this down anywhere. We can just kind of let it go and we'll figure it out. Okay. So we can be like function register, like requests register for, like register for GPU, DMA buff feedback, I guess, is the right thing to do here. And this guy will return the GPU that we want to start with. Probably. Kind of like this. Boom. Client is a client, I guess. Something like this. And I guess we have this allocator here for where this guy's going to come out, which is this guy. And then it's just like this. And then instead of break block, it's a return like this. Bing, bang, boom. Anything else to worry about here? Looks like we're all good. So then here we're just like, this comes up like this. Boom. Desired GPU alloc here. And then we go register for DMA about feedback with this and client. Boom. Surely this can fail, right? Yeah. All right. Oh, well. Desired GPU device. All right. Cool. Cool. So now that we have that, we should implement on the other side. Yeah. So I think that if we run this right now, I wanted a log here. That's what we're doing. We're gonna say, if we don't get anything, we should say here, std debug log warn no GPU provided using default. Provided by compositor. There we go. Okay, cool. So I think that if we run this thing on our window manager right now, this is what we should see. Because we are not sending out these DMA buff feedback things right now. So let's see what happens. If we go zig build, zig out bin, swim, what is it? It's like we do an RM of Wayland 1, run swim like this. That feels about right. I don't know why there's a ... here. Not that it matters, but okay. So if we do Wayland displays this, we run this thing. He looks kind of stuck, which is funny. So he's trying to register for this default feedback thing, and then we just go like, we don't handle that, and we never answer, and so the client's just sitting there waiting, which is funny. Yeah, that's funny. I guess, are we supposed to return something if they ask for something that we don't have? Probably, right? Probably. Like, at least an error, right? Bind. Oh, I guess it's actually here. I guess we just have to implement that. Yeah, okay. So let's first make it so that we at least return something. We should at least error. So in our window manager somewhere, we handle Wayland requests. And one of the things that we do is we say, hey, they had called on this guy. Maybe this guy? Which guy was it? Yeah, it's get default feedback, right? So here we should be able to do something like return self, or it's like a diagnostics make internal error, I guess. Unimplemented. Get default feedback unimplemented, right? Is that all we have to do here? Message and args. Okay. So now if we do this, at the very least, he shouldn't just get stuck there forever. Yeah, he does, right? So he then then we crash in that case, I think, which is funny, right? Because he's saying like, "Yo, he reset." So I guess that means that like every time we return an internal error, we just like hard shut down. Yeah, we do. That's interesting. Maybe we should have some way to do like return an error and leave the connection open, but it's fine. It's fine. Okay. So if they call get default feedback, I think that means that we're just supposed to start ripping this shit, right? So we're supposed to be like, uh, ZWP default, or I guess like feedback interface is like something like this. I don't think we need to write it down for later because we're not going to support notifying until later. So for now, we can put a like note here. If we implement GPU switching later, this will have to be stored and notified. But for now, it's no big deal. Smile. Okay. So we just create an interface for this thing, which I guess is coming from like, where is our bindings.zwp feedback with params ID so that he knows who we're talking to. And I guess we're just like, yo, here's the main device. And we need like to somehow rip out a dev t handle, which we don't know how to do yet. Okay. So where does that come from? It must be like when we boot up, we pick one somewhere. Let's say for now it's hard-coded, because it's hard-coded in the compositor for now, and maybe we should, in here, somewhere we should have a handle to something that can like request that, right? So maybe compositor state will hold like the default GPU. It feels like a thing that is like kind of stored here as a result of something happening somewhere else. I don't know. Because the kind of model is supposed to be that everybody kind of pushes everything through compositor state. So compositor state holds the world, and when things happen, they're kind of like collected by different components of the window manager and put here. Right? The other option is that every single Wayland connection gets a pointer to our like DRM backend thing that has like a function on him to get the render GPU. Both are fine, I feel like. Let's look at like main. Let's kind of like just take a quick peek. I guess it's kind of related to the renderer. So it's like this GBM context where is kind of knows who he's holding, right? So it seems kind of reasonable that we would like stat this file and just send the same fucking dev t over the wire, right? Then it's like depends on who he's selected, but that's fine. So I feel like that's fine for now. So that kind of means that GBM context is going to have something like dev get dev t, I guess. Like this, and he's going to call stood POSIX stat on handle right? Yeah. He's going to be like, here you go. Hello? Fstat? Maybe? Yeah. Something like that. Probably like this. Going to sleep now. Good night. Later. Probably. Sure. And so then this GBM context gets forwarded to like every connection, I guess. Which isn't the end of the world. Where are these connections made? Um, server, probably. Make Wayland server here. So he probably wants the GBM context here. Okay. Something like this. Then this gets stored here. Okay. Boom, boom, boom. Easy. Then this has to make it into connections. Each connection needs a handle to this thing as well, which is maybe a little crazy, but we can live with it for now. Okay, and then he needs to store that somewhere. Okay, easy. I put him after compositor state. And then whoever is responding to that dev t thing, he now has the handle for the thing that he needs. Here, so it's like get dev t is like this. And it's literally just like rip that main device into self writer with studmem as bytes dev t. Feels kind of reasonable, right? Seems pretty reasonable to me. And then do we need to flush here, or does that happen externally? I think it happens externally. Okay. Expected 5, argument 1, 2, 3, 4, 5. Oh, I didn't save. Okay, what's he pissed about here? I didn't write const here. Okay. Oh, and then if this fails, then we need to turn this into an error. So this is like return diagnostics, make internal error of failed to get dev t handle for this reason. But otherwise, we're chilling. What's he visit about now? Expected type main device params found this. Oh. Fine. Area is ignored. Try here. Unsupported field. Field dot name. Whoa. Oh, interesting. Our Wayland serializer doesn't support sending a bucket of bytes. Okay. Write array. Okay. If you say so. If you say so. We are making some big assumptions here, but fuck it. All right. Okay, so now the question is does this work again? So it does look like we did get a main device here of dev DRI card 0. So it looks like it's like this is like send GPU from server. Kind of looks like we handled that. And now we want to select one using some reasonable heuristics. Assign GPU. What does the squiggle T mean in the formatter? That's a new thing in Zig 015 for enums, right? So instead of having to write tag name here with an S, the T does that for you basically. So it's just like the compiler will write down the name of every error that could be returned in this segment. He like puts that in some segment of the binary so that you can like reference that for serialization later, right? Because like in C you don't have that type of like reflection without doing something intelligent. Compiler does it for you. Just kind of sick in Zig. Okay, so how are we going to pick one? So what Kwin does is he looks at all of the options and picks one based off of basically he starts by saying it was hold on, we wrote down device selection. So Kwin selects based off how many internal displays, i.e. LVDS or like embedded display port, I remember being two of the words that they look at, where these are like, you don't have like a physical HDMI cable plugged into the screen of your laptop. You have like something else, right? That like saves space. So they kind of say like, if you're a laptop and you have an internal display, like we want to pick that even if you have like a more powerful GPU. I don't know what a non-desktop display is. I feel like somebody linked me this yesterday. Maybe that explained it. Optional connector property with a hint that the device isn't a standard display and that the console desktop should not be displayed on it. Right. So it's weird that Kwin looks at those then. Hold on, let's look again. Non-desktop. It was something like this. Mock connector. Nope, non-desktop. DRM connector. Where was it where it was like looking at this? Is non-desktop. Is non-desktop. What were they doing here? Where was this? Here. So they were sorting by internal outputs first. This is wrong, I think. That's my guess. Because based off of this explanation here, they're saying like, just ignore non-desktop things for display. Here they're saying, oh, I'm sorry. No, this is right. Sorry, I misread. They're counting if not non-desktop. Dude, classic C++, modern C++ shit, dude. Got it. So, not is non-desktop is crazy. So they're counting monitors that are plugged in. So they're first saying how many like internal displays are there. If they're the same, then pick the one with the most plugged in monitors. And if those are the same, pick the one with the most monitors. That's what they're saying here. So how the fuck do they do that? There must be some sort of like DRM function to count number of plugged in displays. There must be. Which means in our world, we probably want to go to like DRM render backend in here somewhere. And in our like API here, what do we want to return here? It's like, it's hard-coded here too. So I guess this guy wants to pick a file here when he's initialized based off of whatever heuristics he feels like. Then in this like render backend interface, he wants to export like you know, selected. Well, he has like a file descriptor. But can you go from file descriptor path? POSIX path from file descriptor. Is that like a thing you can do? Um. Boom, 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 boom. Yeah, I mean, I wouldn't be so shocked if there's not really an answer for this. Because, like, you can have file descriptors for things that aren't on the file system. If I called open on a path, now I have a file descriptor. Can I get the path used to open the FD back through some POSIX call? Question mark. Let's see if he says yes. Because like I know that like the if you do like ls-l in proc, that information is like available. Read link. Yeah, okay. So that's exactly what I was what I was just saying, right? You can check the symlink in proc fs. But fuck it. We just won't do that. We just won't do that. So we can in here. Maybe it's like this. We kind of store the like device path here. And then on init, we figure out which one it is, right? So someone's gonna be pissed here. So here we go. Device path is dev dri card 0. Interestingly, the null backend, how do we select if we don't have anywhere we are rendering? Question mark, question mark, question mark. But for now, he will just hardcode dev dri card 0. Fuck it. Maybe he should just pick a render node or something as well, but we'll see. So we have our like actual implementation that works on DRI, and then we have this like thing that doesn't actually do any rendering. This guy should do something more intelligent now, right? What is this allocator for? Like, does he expect this thing to be long-lived? Looks like it. Okay, cool. So we can allocate on this allocator and stick that somewhere, right? So it's like function select select best GPU. And he is going to do something like probably. Oh, this is interesting. So he has to like iterate over all file handles in this folder, right? So he's got to do like open dir absolute or something, right? Dev dri. He's gonna look in this folder, and we like iterate. Yes, please. Yes, please. I would love to iterate the file handles in this directory. Defer dir close. You know, in the future, this is going to have to be something that like responds to events of like when things are added, removed, plugged, and unplugged, etc. But for now, we'll just do it on init. Iterate while iterator next. We have some entry, right? And for each entry, we're gonna be like can we get like get selection info, get GPU. Let me think for a second. I guess since we only have to select the best, we're gonna have something that's like GPU selection info, right? And if we do what kwin does, we're going to say like num internal displays, num external displays, right? And num display ports, right? And then we're just going to say like is better self GPU selection info if this is confusing. This is a confusing API because it's like who am I claiming is better, me or the other guy? So if other is better or something, it's gonna be like other if other num internal displays is not equal to self num internal displays, return other num internal displays is greater than self num internal displays. Easy. And then we do this for external. Okay, and then this is return self num display ports is equal to other num display ports, right? Okay. So this loop is going to start looking like this, right? We have we start with one that is 0, 0, 0, I think. And I guess here we have a path here as well, right? Like this. We start with one that is defaulted out like this. We say best is GPU selection info. Okay, easy. Easy peasy. Then we say like for each of these guys, we do maybe entry info is GPU selection info from file or something, and we do like dir open file entry name or something. I don't know, man. Maybe, yeah, I think it's like this. As I'm just learning Zig, do you ever actually use error defer? Okay, we did a whole saga on this, because in my opinion, error defers are a source of danger, right? Because I found that it's very, very easy to do something like x is alloc, some bytes. Let's say that maybe it's like, I'm trying to find an example. Maybe you have some function, some function returns 2 strings, right? Let's just say that there's a function like this, right? He returns 2 strings. And so in here, I'm like, const x is alloc u8, right? 10 of these. And y is another one of these. And I'm returning, x, xy, right? Something like this. In this world, you're going to do something down here where you're like, check x and y or something, right? And this thing maybe fails, right? So this thing can fail. And so here, then you're like, okay, in this case, I have to error defer alloc free x, right? And alloc free y, right? Now, it's very, very, very easy, in my opinion, to do what I just did here and copy paste this error defer and forget to change the variable name, right? Which means that like, and also, if this check usually passes, like in every single test that you ever run, because like this thing maybe like allocates, it like will fail by allocating or something, like you'll almost never hit that case ever in testing, right? And so if you have this case, you've got like a double free here that you just like will never ever fucking notice, right? And that bothered me, right? So my preferred approach is to do it like this, where I have like pool, some like thing that frees in batches. And then what I do is I do this, right? And somewhere up above, I'm going to call some function. So I do like, some other function And in here, I might do like, you know, pool checkpoint or something. Pool, or like even just like make pool, right? And then no matter what, at the end of this function, I'm going to destroy this pool, right? And that means that now when I call some function, because I'm passing in like a pool for allocations, my like failure case and my non-failure case are just the same. And so I don't have to worry about this like, oh, I didn't like I didn't handle these errors correctly, because now I've just like re-architected my code so that the error case and the success case are the same. And that just means that I'm hitting the error, I'm hitting that cleanup case every fucking time, and there's like very little chance of me having fucked that up. So I prefer to like structure things this way. It also like prevents a lot of other problems, like forgetting to free and stuff like that, like leaks and stuff. They just like don't really happen anymore because of this like lifetime way. But it also means that like a lot of the code that I've written is like I have to go out of my way to make that work well. Right. So I wrote like a whole set of allocators that kind of like work well for that setup. And then like because of the, you know, now I'm like kind of into these like linear allocators, because you know you can kind of like keep your whole thing on the stack, never even call malloc, which is kind of fucking sick. But if you're using linear allocators, then all of your types have to be kind of like linear allocator friendly. And so like, you know, your array list is not like a linear allocator friendly type, because as you grow your array list, you're wasting space back in your old allocations because you don't support free anymore. So there's all sorts of like things that make it maybe not great. But generally the idea of like pooling so that I don't error defer, I'm a big fan of that now. And also like batch freeze can be a lot more efficient, which is kind of nice too, right? Now I also for the same reason, if I have like a deep like a node tree, right? If I have like some sort of like tree of things that are pointing to each other, when I clean up, I don't have to like walk the tree and free everything. It's just like, oh, I'll just like nuke that pool. So it has some benefits, has some downsides, but I just found for myself, I'm not thorough enough to be content with having error defers around my code. So I don't use them that often. I do sometimes still, because sometimes you have to. But yeah. What's surprising is that kind of memory management using arenas is not really that common in C, where people would benefit the most. Yeah, I'm surprised it's not more common as well. I would have thought that everybody, like, just because of the fact where I'm like, I'm scared of double freeing. It's like the natural conclusion, I feel like. So I'm surprised it's not like the default, but maybe it is in some circles. Okay, so this guy, he's going to take some sort of file. And he is going to return a GPU selection info. So presumably he has to like open it and do some sort of like DRM negotiation of some form. Right? So he's gonna like open this thing, probably close it unconditionally here. We'll just open it again later if we decide that this is the one we wanted. Oh, he's already open actually. He does have to be in read-write mode though, so oh, this is actually no, this is wrong. This is a path. No, okay, so this is here. Mode equals read write. Okay. Then here we have a file, so we're chilling. Which means I guess we actually do have to do this. Because we do have to close the file, or else we're gonna leak it. So it's kind of like more like this, like this, like this. Okay. Maybe for unit types we're part of the standard library. Yeah, I guess it's just like malloc is in libc and an arena isn't. And again, like all of your like the fact that when you have like linear arenas, you can't just have like strings with like nice strings are kind of harder to come by. So I could see a world where it's just like people don't want to take that. Okay. So I guess we have to start looking at like what is in these things. So we have mode res. Okay. So this guy already has like count connectors on him, so that's a huge win for us. But I guess we need to query each of them, right? So is it just like for resources count connectors? It's like Is it even like resources connectors from 0 to resources count connectors or something? Is that what this is? We then have this connector, and then we like query information about it, right? So here we go like see Durham. Where do we get connector current? Where is that? Here we go. DRM mode get connector current, which returns one of these. I didn't know you could do this. That's kind of neat. I guess it makes sense, but I've never seen this declared this way before. That's fancy, fancy schmancy. So what are we looking for here? Like connector type, and if it's connected, DRM mode connection probably. It's not uncommon in C, it just depends on the space. Makes sense. Makes sense. More embedded code often uses arenas are similar. More ballot calculation methods also depends a lot on how people build APIs in lifetimes. Also, passing allocators around in C is not common as newer language. Makes sense. Makes sense. Okay, so this thing tells us if it's plugged in or not. This thing probably tells us the type of the connector. So who? Is there some enum defined for this somewhere? There's got to be, right? What do they do in Kwin? They have like a is intern like DRM output is internal. They're looking at M connector, which is a DRM connector, is internal. So they're looking at DRM mode connector here is the type. Okay. So we're looking for, what was it? DRM connector current or something? Get connector? Get, I lost it. DRM mode get connector current. Okay, here we go. Connector is C DRM connector? DRM mode connector, of course. My bad. DRM mode get connector current. Right, it was like this. F handle. Okay, so we have like connector dot connector type equal, and we are switching if it's like is internal. Connector type here. So they were doing this, right? Which we will just full on yoinkies. Oopsies. There we go. Boom, boom, boom. Fully stolen from Kwin. And then they have the like is non-desktop as well, right? Where does this come from? So they are querying this like property of this thing. How do we get that from our world? What the fuck are they doing? They have like DRM property, and they are calling Jesus Christ, man. There's some properties thing that we can call and we compare, right? DRM mode connector props here, right? So we're looking for, I don't know how this works. DRM mode prop get property type. What a crazy API. DRM mode connector properties. Let's see if someone online will tell us what the fuck I'm supposed to do with that thing. Properties. Connector? Yeah. So these guys have properties in their like mega struct here. How do I work with the properties on the user space side though? I guess we could just look at what the fucking kernel gives us, but I'd rather not. Um, yeah, but these all look like internal fucking Linux kernel APIs. So fine, we'll just look at how they convert them. Fine. What is this? Like DRM mode get DRM ioctl. Yeah, let's go here. Like connector. DRM ioctl CPP. C. Sorry, forgot what language you're in. Connector. Here we go. Get connector. DRM mode. Get connector. Where is this defined? Bump. Properties. Okay. So they are looking over DRM mode object get properties. Who does what? Who defines this? This guy. Okay. So he's calling DRM object property get value. Okay. Who has object properties values at I? Sure. So this guy has some sort of like properties array somewhere, and each index maybe corresponds to something. Prop pointer, prop values, right? So here he's looking at foot user, the property base.id, and he's putting that at this offset. Yeah, so there's property base ID that gets assigned somewhere for each property, I guess. And then how do we like get their name? Like presumably there's some sort of like name retrieval for this thing as well. Property get property returns a property pointer with name here, right? So I guess we're supposed to look at each property, then get the property with DRM mode get property, check its name, check if the name is non-desktop, then use that to determine if this is a non-desktop display. Right? It looks like that's what we're doing. Okay. See DRM mode. What is it? Like, there's some free function that we're supposed to do on these connectors as well after that isn't resolving here. Free connector. Okay. Maybe this is like continue here if we fail to get this. Warn failed to get connector properties for connector this. All right. Something like this. Okay. So we say Is internal is this thing. Ooh, easy. Right. I think we forgot this needs to be or in this language. And these need to be C dot here. Okay, and then we say like is non-desktop is, I guess we need to like figure out what the property ID is for is non-desktop. Maybe not, we'll see. Is non-desktop. And this is gonna be on like connector properties. Maybe something like this and connector values. You know, something like this. I guess this should be a slice actually. And then it's like for connector properties prop, we're going to call like DRM mode get property on prop, or else return error no property. Mode property or something? Defer C DRM mode free property, probably. I don't know, I'm just kind of making up the function names based off of the naming scheme I've seen, and we'll kind of figure it out when we get there. Okay. If it's not internal, I guess. I don't know. I haven't figured this out yet, but it's like something like this. Yo, thank you for the prime. Much appreciated. What is it? I wish the fucking autocomplete worked on this thing. It's props and prop values. Props, prop values from 0 to connector count props on both of these. Something like this. Okay. Boom, boom, boom. And then what are we doing this with this? Is non-desktop is if we're not, if is internal, false, else we do this hard work. Yes, something like this. Okay. And then we say like count internal displays plus equals if is internal 1 else 0 count external displays is if is non-desktop 0 else 1 num display ports count display ports plus equals 1 or something. It's like something like this. Count internal displays equals 0 external displays equals 0 display ports is 0. Something like this. We're getting close. Path is, I guess we should be passing this in here. Sure. Path is path, num internal is count internal, internal goes to external, and then num display ports. Oh, honey, would you love me, love me, love me? Dude, this song's such a fucking banger. This is probably like the song that I've like disagreed with most. Like the lyrics are so bad, but the song is such a fucking bop. He's just like, if I had more money, would you love me? And it's like, surely no, right? Surely you're a piece of shit. But man, if that song hasn't been stuck in my head for like how many years? 15 years? Like, it has. What can I say? All right, what's going on here? So here we are looking if name. We're looking for like a stud mem span of this guy to turn him into like a null, to figure out where his null termination ends. And we're like, if stud mem equals u8 name of non-desktop, it's like return connector values. It's like return val is greater than 0 or something. I don't know. It's probably something like this. This is prop ID here. Yeah. All right. I guess here it's not non-desktop if they don't say anything about it. Would be my guess. Something like that. Okay, so then can we select best GPU? Is this thing done? No, we didn't finish this. So here we need to say if best other is better entry info, best equals entry info. Here we need to pass in the entry name here. And then here it is, we need an allocator here to find the path of this thing. And it's like stud fs path join on this allocator dev dri and whatever we fucking picked. Best path. Something like this. Yeah. Okay. Best GPU equals this. And then we're like, use fucking best GPU, baby. Yeah. Sure. And then we write that down over here. All right. That's like a maybe. Okay. All right. What's he pissed about? Expected U size found scient. Int cast. Okay, another one. Another one. DJ Khaled. God. All right, what's he pissed about now? Expected bool found this. Oh, try here. Okay, this is pissed because there's no DRM mode property. What is it? DRM mode property. Pointer. This thing probably needs like F handle or something. Handle std posix fdt or something. So this guy needs like F handle here. Something like that. Okay, then this thing. Oh, this thing actually needs to be more like this. Res, because otherwise it could be null. He doesn't like that shit. Invalid type given to span. Interesting. Yeah, he's looking for like null terminated, right? What the fuck? Why is he thinking that this thing's like U32? Name is char? Wait, what's the problem? Wait, this actually feels right. Bum, bum, bum. 32 U8. Oh, am I supposed to put a little ampersand on this? Probably. Still no? Oh. He wants this. He wants a little pointer cast because this thing's like char is signed. He wants unsigned or something. Yeah, there we go. Are you using a gaming laptop? Nope. Nope. I've on a desktop on a tower. that has been slowly cannibalized for the last like 20 years. I think I still have the same case that I had 20 years ago. Just with less fans because they keep breaking. Um, I did like a recent replacement though, because like I think like a couple months ago, maybe 1 or 2 months ago, my motherboard just like totally fried, which means I got to upgrade my CPU and my RAM and my motherboard. So now it's pretty sick. My when there's no audio playing, my speakers don't just crackle all the time, which is like a big win. Huge win because the motherboard like and also it boots. Another big win. Okay, so I guess to test this stuff, um, we need to run it in our virtual machine where we have access to a raw DRM window. Now, people will sometimes ask, why the fuck do you do this in a virtual machine instead of on your computer? And it's because I'm streaming. If I go to a different, like if the window manager is what you guys are seeing, so I get fucked. We have to do a virtual machine, or I have to have dual PC streaming. So what you gonna do? What you gonna do? Okay, so let's see if we select a reasonable GPU now. Failed to init render backend, so that's bad, right? That's gotta be a result of this new code. It's gotta be. Can we at least log Y? Actually, maybe it makes sense that for whoever is making that decision, we should be like if error trace, if we have something we can look at. Let's fucking dump that shit. All right. Hello? Oh, my bad. No, wait, I'm confused. Oh, because this is an info log? Fine. Hello? Fine. Fine. Is dir. I see. So in select best GPU at 325, he's just like, that's a fucking directory, you fucking dumb fucking idiot. Okay, chill. Yeah. Entry dot kind is equal to file or something. Is not equal to file. Continue. Fine. Like if you're gonna fucking be like that. I guess character device is actually more what likely to be what this is. Is dir at 325 again, huh? Maybe I didn't compile. I feel like I did, but you never know. Get resources now. So this is in select best GPU from file at 329. Okay. Failed to get GPU info for this skipping. All right. Fuck it, you know? Fuck it. Cross compile, copy over. QEMU the poor man's dual PC. Yeah. Okay. So I don't really know if this means that we picked something. It looks kind of like no, right? He's failed to poll. Did he pick a bad GPU? We should log what he picked, huh? We should write that down. Stud log info picked rendering on GPU this. Okay, so he picked dev DRI card 1, but I think that our card 1 is like fucking busted. Like he's been busted for this whole time, and that's why like we have 2 at all, is because we never figured out why rendering on like the original default card doesn't work. So can we like detach that from the virtual machine? um or like disconnect the monitor from it at the very least. Like, is that a thing I can do where I can say like uh like like if this card is here, I want it to have no monitors at least, right? I would like to see, maybe we should at least log why it's winning. That might be interesting. So we can say if other is better, stud log debug, other is better, has more internal displays than this, right? Other path, self path. And we can say has more external displays, has more ports. Okay, let's try that. And then really should have like a scope log here. But whatever. Whatever. For now, let's just do this. Log levels debug globally, and we cross compile for Moosel. We run it over there, and let's just see what he does. Oopsies. Okay. Card 1 has more external displays than null. Card 0 has more ports displays than card 1. Okay. Oh, wait. Hold on. Okay, and then this should be actually like this. More, less. It's more like this. If ret. There we go. Okay. There we go. That's a little bit more accurate, huh? So he goes, card 1 has more external displays than nothing. Card 0 has more... Why do I feel like... Like, it doesn't say that anymore. Why do I feel like when I SCP this thing and then Alt-Tab over there, it's like running old shit? Yeah, so it's literally just like card 1 has more external displays than nothing, and then card 0 has like the same amount of displays, right? So if we plugged in a second monitor to that second card, then we would be chilling. But like from this case, it's like equivalent, so he just kind of picks one at random. So like maybe we like lexicographically sort at the end, right? So if they're the same, picking whichever one has the lower ID because the BIOS picked that one seems kind of reasonable. But in reality, in our case, we can just turn off the second display. So how are we doing this? We are saying device vert IO GPU. How do we like disable QEMU, disable VGA or whatever? Or like QEMU vert IO GPU. Right, like how fuck. Command line. I don't know why I clicked it again. Like, didn't work last time. Here. Will this be your daily driver when I manage it? That'd be kind of cool. It would be cool. So like I've like added this device, but I want to like also remove the other device. QEMU disable default device. I guess we'll just ask the idiot. How do if I run QEMU with this, I get a second GPU with vert IO GPU driver. However, the original QXL, is it QXL? We should double check so we're not fucking lying to him and confusing him. He gets confused easily. Poor guy. Okay, root probably lsl dev dri, by path, like sys probably bus PCI, like devices. What is on 00002? Wait, am I confused? Does it not tell me what this is? I thought it tells me the driver. If I look at this. God damn it. Box. Box. It's box. Box. The original box GPU is still hooked up. How do I turn it off? There we go. VGA none. Yeah, there we go. Okay, nice. We'll see if that does it. I'd believe it. Nice. Sometimes he hits. Sometimes the idiot, he's not so much of an idiot. He's still an idiot for sure. But, you know, sometimes it's not that bad. All right. This time he picked card 0. However, somehow he still managed to, like, fuck shit up. What is happening? Oh wait, that's normal. I forgot. It's just because we turn on debug logs. This is just a normal thing that happens. I forgot. Okay, so that means that we should be able to run this again. Swim. And we should be able to be like Swayland client here. Wonderful. Everything is back. However, we are not propagating that information back to the client yet. So we need to tell the client that it is what to do. We need to say propagate selected GPU. Propagate. So I think that the only thing that we're missing here is after we've picked this guy, we just have to go to like main here. And when we initialize OpenGL here, I think we just pick like render backend dot device path. And I think that should be enough to basically remove almost all hard-coded dev DRI card zeros. I think. Holy typing speed. Dude, I played so much Type Racer in university. So much. Yeah, sick. Sick! We're so back, baby. Okay, cool. So I think that's an overall success. It feels like we got rid of almost all of them, right? Git grep grep ri card 0 in source. So we basically just have it in the null render backend as like we just pick it for funsies, and then we have like a fallback card in our window manager for if they don't give us one. But everything else is like dynamically detected, which is sick. Which is sick. Theoretically also, we should be it's probably better for us to tell the clients to use the render nodes instead of hard coding card 0, because I think technically you could have like a little bit better, like more permissive permissions on the render node, because it like there's kind of like two for each device, right? There's kind of like card 0 lets you like everything, right? And then this is kind of like linked to like render d 4, 5, 6 or whatever, and this is like rendering. you know so technically, like, our window managers don't need to be doing stuff like iterating how many connectors there are, right? He only really needs like to be able to draw pictures. So we should be giving him the less permissive one. As you can definitely see, these letters say render D456, and you remember that, and you can read it with your eyes. Yeah. So, but overall, big win, big win. So I think we call it there. That's a perfect 4 o'clock end. Are you trying to pass the GPU to QEMU? No. We're just using QEMU for testing of the window manager we're writing. So we're just using it because I can't easily stream myself running the window manager on my native machine. But we'll get there one day. All right, cool. Almost a perfect 4 o'clock end. Thanks for watching, guys. If you like what you saw, we stream most days 12:30, 4 o'clock Pacific time. It is 4 o'clock now, so anywhere between 3.5 hours going now. You should expect to see us live. A lot of the stuff goes up on YouTube, right? So there's a YouTube link in the Twitch description if you're watching live and you want to like keep up. Not everything goes there, right? So we kind of split the stream in 2 halves. One is like kind of cleanup, reading, investigation, that type of stuff. Today we were working on just banging out the last few pieces of our dbus implementation so that we can work on the systemd login deintegration in a main VOD for later. But we put that stuff, we archive the first half on Patreon, YouTube members, or Twitch VODs. If you pay in the appropriate place, that gives you something that you can get if you want to support the stream, because when I run out of money I have to get a job. But also it's too much stuff to post on normal YouTube all the time. So if you want everything, please consider supporting, but obviously no pressure. Otherwise you don't really miss, you can follow along fine without that part. Anything else? No? YouTube, peace out. Twitch is fun, someone to raid.